Hi, and welcome to this informative session about the Structural Engineering Library, where our purpose today is to cover the Loads and Forces division seen here in the Project Manager. Now, just for reference, I would point out that I've created a brand new file for the purpose of creating this video, and I'll also point out that I'm currently using build 6.12.4.24, just for reference. The Loads and Forces division is one that comes into a brand new project file automatically, and if I expand its contents here, we can see that it covers a variety of different potential loading items that you may want to incorporate into any project file. In a general sense, I'd point out that the Loads and Forces division was fairly recently separated out to be its own division to try to elevate its status and to acknowledge the importance of the calculations that are performed in these modules, to make it a little bit easier for you to organize your project files and to make things a little bit more convenient to find and to edit and to print. The other thing that I'd point out in a general sense is that it's organized so that it contains some items that reference seismic loading, some items that refer to wind loading, and then we've got some snow load items and live load reduction items. And then the last general thing that I would point out about Loads and Forces is that it is an ever-growing and ever-expanding list of calculation items. We try to incorporate and incorporate as much as we can and enhance this area as much as possible, with the expectation that it's an area that is useful to users of the Structural Engineering Library for the calculations that take place there in the Structural Engineering Library, but also with the hope that if we can fill in some of the gaps in the loading calculations that are required to support you in the use of some of your other pieces of software, some of the more high-end analysis and modeling and design type software that's available to you as structural engineers, why we're happy to do that as well and to lighten your load so that some of the preparatory work involved in setting up those more advanced models is made that much easier as well. So that's kind of our hope, is that we can make this Loads and Forces module general enough so that it's extremely useful to a wide range of structural engineers. Now, I'm going to work down through the list and just briefly mention the items that are currently in the Loads and Forces module, and then I would point out that we'll create separate videos for each of the individual items and go into much more detail on what they contain and how they're used. So look for those videos separately. Starting at the top of the list, we have an item that handles the calculation of seismic base shear in accordance with ASCE 7, and I would mention that it is now updated so that it calculates seismic base shear in accordance with ASCE 7.05 as well as ASCE 7.10. The next item down is for the purpose of calculating seismic demands on non-structural components, and this one is also in conformance with ASCE 7.05 and ASCE 7.10. The third seismic item is one that's specifically for determination of seismic wall anchorage forces and wall design for seismic loads, also in accordance with ASCE 7.05 and ASCE 7.10. And this one was recently separated out from the seismic base shear module, where it was previously just basically a single line item as one of the steps in the seismic base shear calc. We recognized the need to enhance the module, to update it, and to expand it so that it could handle multiple wall conditions on a project. And so that's why it now sits out here at the same level as the seismic base shear module itself. The next item down in the list is one that was introduced for the purpose of determining the wind enclosure classification for a structure in accordance with ASCE 7.05 and ASCE 7.10. And this was done because in some of our other wind loading modules, what we've done in the past is basically just provided information for both enclosed and partially enclosed structures, and we left it up to the user to decide which category to read from. The calculation itself is not difficult. The determination of enclosure classification is fairly straightforward, but it can just be a little bit tedious. And so what we did was we created this worksheet that simply collects areas of openings and areas of gross wall expanses, so that you as the user can populate those values and work your way through a logical thought process to let the computer make the determination as to whether a building qualifies as either enclosed, partially enclosed, for wind on a given elevation of a building, or potentially if a building actually qualifies as an open structure. So this module is here and is available for use in a general sense in determining the enclosure of any structure that you can quantify. The next item below that is the brand new ASCE 710 wind forces module, which is for the main wind force resisting system. This module conforms to Chapter 27 of ASCE 710, which is the directional method of determining wind loads and pressures on a building. And it's a significant departure from the predecessor module, which is the ASCE 705 wind forces module, because the one that's based on ASCE 710 actually goes beyond calculating pressures, and it goes all the way to the level of calculating forces, both story forces and base shears and torsions. So if your building is one that can be approximated by a box shape that is of dimensions B by L by H, then we think that the ASCE 710 wind forces module is going to be a welcome tool, because it will take those calculations for wind forces so much farther than its predecessor did. And I would also point out that because we now have the logic for the wind enclosure classification, we incorporated that into the ASCE 710 wind forces module. So as you work through the tabs in this module, you'll encounter that enclosure classification part of the process, and it'll incorporate that calc and then immediately report those values and use that decision in its further calculations. So a very important new addition to the structural engineering library here with the ASCE 710 main wind force resisting system calc. Its little brother, or perhaps even a little cousin, is the ASCE 705 wind forces. Still a very useful tool for anyone who is basing wind loads on the simplified procedures of ASCE 705. Granted, it is somewhat simple in the sense that it only calculates pressures, and it leaves the distribution of those pressures and conversion to forces up to the user, but nonetheless a useful tool here based on ASCE 705. Rounding out the offerings for wind loads, we have the last item here, which is the one that calculates wind pressures based on the alternate all heights method as presented in IBC 2009. Then we move down into the snow loads category, and I would point out that this is one label that will quickly be updating to be a little bit more generic, because it indicates ASCE 705, but the module is actually general to both ASCE 705 and 710. So this module will allow you to calculate your roof snow loads, both the balanced snow load as well as a tab that will allow you to specify the parameters and determine a list of different drifting conditions that may exist on your project, and it'll calculate the maximum intensity and the width of the drift and so on. So a very useful tool for studying situations where you have uneven snow loading conditions that need to be evaluated. And then finally here in the list is the live load reduction, which is really both live load and roof live load reduction. Again, general to both ASCE 705 and ASCE 710. And it provides the opportunity to create a list of different conditions on your project, consisting of both live loads for occupancy as well as roof live loads, and provide the tributary areas and the other parameters that are required in order to determine a permissible reduced live load or roof live load that could be used for the design in those different areas. So I hope that this general walkthrough is useful in terms of letting you know what's available here in the Loads and Forces module, and keep your eyes on this area because we anticipate it'll be an area of focus for us, and we'll certainly try to continue to enhance that so that this area becomes even more and more useful as time goes on. In closing, we'd just like to say that we welcome any suggestions from the user base. So if there's anything in particular that would be useful to you, that would fit in nicely here in the Loads and Forces division, please don't hesitate to get in touch with us at support@enercalc.com and give us your thoughts on that. We'll be glad to give it some consideration and see if it's something that we can potentially incorporate for future builds. Thank you very much for your time, and have a great day.